Welcome to Fish School episode 3. In this episode, we make the Snot enemy and program our first component. We'll start with the Snot, create a humble cube and name it Snot. We could have a green cube as a placeholder, but we uploaded a Snot model just for this tutorial. Go on the cloud browser and look it up. You'll see this one made by Smallfish. Let's select it. And as for the collisions, I think a cylinder collider will work better than the box one. The component we're looking for is the hull collider component. In this dropdown, you can select the cylinder and fit it around the model. Place it down and play the scene. Right now, our Snot is nothing more than a static prop with no animations, but our model does come with animations. They are not showing up because we used a normal model renderer. If you look at our player model renderer, you can see it's a skinned model renderer. Skinning is the process of attaching a 3D model to a rig and using said rig for animations. Right-click on the Snot's model renderer and select Replace Component with the Skinned model renderer. It will try to copy every property possible, but over here we'll have to select Use Animation Graph for the animations. And while we're at it, let's do like the last episode and create a separate child for the model renderer. Just select the model renderer and drag it into the child and go with Move Skin Model Renderer here. Play the scene and the Snot comes to life, goes by its idle animations squirming about. If you select the Snot model renderer, you can see we have a few animation parameters we can play around. A procedural hit animation based on the damage amount and the health slider, and finally a death animation. All we need to do is hook them up, and actually the citizen comes with similar animations as well. So let's figure out what we need by seeing what they have in common. First off, our game will have 3 types of units: players, turrets and Snots. We know all of them are going to need health, which includes being damaged, playing the hurt animations when available, and lastly dying. Since they use different animation parameters, we'll need them to be configurable as well. Then, we also need a way to distinguish teams. We don't want players to hurt each other after all, that can be just a property. And speaking of health, they all need a way to attack each other. Realistically, only the player has animations for these, because both the Snot and turrets will have something different, but all of them need a defined attack range, amount and cooldown. All of what I've listed so far can be done with a single component, one that defines everything you need to know about a unit. We'll call it Unit Component. And now for the single-use components, ones that only serve one purpose, this Snot will need to multiply itself. That's pretty unique to them, so we'll have it be just its own component and probably call it multiplier component. Then there's the turrets. They'll need to rotate towards this Snot and shoot fire. That's also pretty unique to them, so maybe point and shoot component. And lastly, we have the player. We already have a player controller, but if we want to implement punching and interacting, we'll have to handle it ourselves. Snot player component. Now that we have a rough idea of what we'll need, let's create our first, the unit component. If you go to add a component, we have the option to create a new one. Let's name it Unit Component and select the Shrimple Component preset. After creating the component, it will open it automatically with your default code editor. If you don't have one set up already, just go to Edit, Preferences, and you can select it here with this drop-down menu. Then you can right-click, open Unit Component, or go to Project, Ctrl-P. Let's go back to the code. All it contains is your class, which derives from the base component class using the S&box namespace, which is what is needed for the component. The base component class has many methods we can override to run code, and here you can see onUpdate, which is going to run code every frame. Since we didn't make these methods, we have to make sure that the way we write them is the same way they were defined. In this case, they are protected, meaning you can't call them outside of our class, and they return nothing. Doing it any other way won't work. Here's all of the methods you'll need to know for now. We have onUpdate, which is called every frame, onStart, which is called when the component has been created and before the first update. This is where we'll put our spawning logic. On fixed update, which is called every tick, basically a fixed rate regardless of your frames per second, 50 times a second by default, and lastly, on destroy, which is called when the component is being deleted. There's a few other methods that we won't look at right now, but these are the ones you'll encounter the most. We don't need to call the base method, because we know that the base component doesn't have anything in them. Now let's add properties to our components, starting off with the name of your unit. And to have it display in the editor, we add the property attribute. Remember the getter and the setter, we'll explain them later. If we save with Ctrl S, you'll get a notification telling you that there are no compile errors, and in our component, we can now see the name property. We can go and add a description to the property. Some code editors make it easy by autofilling it for you when typing 3 forward slashes. And when you hover over the property, it gives you a description. We also need a property that defines which team this unit is. In our case, we'll just have players and Snot. I'll make it fancy by using an enum. Outside of your component class, let's define a public enum called team type. And the only two options being player and Snot. To make it even fancier, we can use more attributes. One for an icon and one for a description. The icon attributes takes in an icon name which uses the Google Icons pack you can find in the description. Just select one and copy the icon name and paste it in. Although I'll use emojis instead because I doubt Google has a Snot icon available. A poop emoji for the Snot and a person emoji for the player. I'll leave the emojis in the video description if you want to copy and paste them, then fill up the description attribute as well. Add a team property inside of our component. Save. Yeah, sure. And now, this nice drop-down menu appears, looking awesome with the icons and descriptions. I'll select Snot. Let's look into implementing the max halt in the form of a float. Set the default to 100, and let's make this a slider in the editor, so we don't have to write it in. Add a new attribute to the property called range. First argument is the minimum value, let's do 10, second is the maximum, I'll put 300, and third is the steps, I'll also do 10. Save, and let's look at it. Drag it around, and since the steps is set to 10, it will go from 80 to 90 to 100, with minimum being 10 and maximum being 300. I'll go 50 for this Snot. Now this is the max health, but if we were to damage this Snot, we don't want to modify this property, and also we want to play animations, sounds and particles when this Snot gets hurt. So to make sure it's done correctly, we'll have to make use of the accessor methods, set and get. To do that, let's create a private health field, so that nobody but the class can modify it. I've written it lowercase and with an underscore because that's a common naming convention for private fields. It's not necessary, but it's good practice to make them look different from public properties, and as opposed to properties, which are always public and have these accessors, fields can be private and are usually used to store data. On the outside, these empty getters and setters make the property act like a normal field, but on the inside, this is what they look like. We make a new health property, but this time the getter returns the health and the setter sets the health to the given value. When trying to get the public health property, it returns the private health field, and when trying to set the public health property, it sets the private health field to the value. For example, if you divide the given value by half and set it like this, Instead of setting it to 100, it will set to 50 instead. Let's actually set the health to its max value when spawning in. And remove this, whoops. Override the onStart method and directly set the health field. This is probably the only instance we set the field instead of the property outside of its accessors, just because we don't want to play any effect or animations when it spawns in. Now, for actually implementing what we wanted, let's create a private update health method. Meant to be run only inside of this class, which takes a new health float. Calculate difference between current and new. Set the private health field to the new health, but clamp it between 0 and max health. Now let's replace the setter with this new method. And remember, when we are inside of the public setter here, we set the private field and not the public property, or else it's gonna cause an infinite loop. Now finally, let's hook up the animation parameters. We'll first need a reference to the skinned model renderer component. We'll do that with a property in the editor. Public skinned model renderer, save, and in the editor, to fill out this component property, we can either use this eyedropper and select this Snot, or you can directly grab this body child and drag it in, which will also find the skinned model renderer for you. Now that we have our reference set, let's just quickly see what the name of the parameters were, so we know what we need to set. First off, we'll need the hurt animations, which use the damage float 0 to 100 to determine how severe the animations will be, and then the hit boolean to play the animation. In this case, the hit boolean auto-resets to false when setting it to true. Go back to the code, and before handling animations, let's make sure not to run any code below if the model renderer isn't valid. If the model renderer isn't valid, then return early. It's good practice to always expect the worst. If the difference is negative, then it means we lost health and took damage. For that, let's create another private method that handles both parameters called damage animation, and it takes in the amount of damage. On the model renderer, set the damage parameter to the damage float we just passed. And then set the hit boolean to true to play the animation. Let's put this inside of the update health method by feeding in the difference, and actually the negative of the difference, because this will be negative and we are expecting a positive value. One last thing, we also need a health animation parameter going from 0 to 100. Let's set that outside of the damage animations, so it also works if the difference is positive, meaning it healed. Set the health parameter to our health, but actually our animation parameters go from 0 to 100, while we set our Snot's health to 50, so those are never going to match. We'll need to remap it so they work for any amount. Inside of the damage animation brackets, let's do a remapped damage variable. With the useful mathx remap method, we can remap the difference, negative of course, so that instead of going from 0 to max health, it goes from 0 to 100. So since the max health is 50, if it gets 30 damage, it gets remapped to 60. In our case, think of it as a percentage. 30 damage out of 50 is equivalent to 60% of 100. Don't forget to plug it in, of course, and let's copy and paste it for our health. Just gotta rename it, use the current health, and plug it in. We're almost done. All that's left is to play the death animations when it reaches 0 health. If we go back, you can see we have an animation parameter called dead, and this time it won't auto-reset like the hit boolean, so if we set it to true, it will remain true. If the health is lower or equal to 0, we set the dead parameter to true. Simple enough! We don't have a way to damage this Snot right now, so let's make a new public method, accessible to anyone, that takes in a float for the damage. All it does is take away the damage from the health property. It's so simple because all the logic is done inside of the setter. Let's add a quick comment so people know that they need to plug in a positive amount to hurt and a negative amount to heal instead. And now I want to test it out. Let's make two debug methods. One to hurt by damaging with 10 and one to heal by damaging with -10. By adding the button attribute, we'll be able to call these methods inside of the editor. You can even add icons to these buttons. Let's also do a third option for a massive amount of damage, to see the difference between animations. Save, and finally, if we play the scene, when we press these debug buttons to hurt this Snot, not only does it shrink because of the health animation parameter, it also plays a little hurt animation, but not when we heal it. And if we do a large amount of damage, it will recoil even more, until it reaches 0 health, and plays the death animation, shrinking into nothing. That about wraps up the episode. One thing to note is that what we made with the unique component should work for everyone, but as you noticed, we only play the Snot animations. So in the future, we'll need a way to make it work when the player and the turrets also get hurt. Thank you for watching, and join our Discord.